Hi, I'm presenting to you today CD-Square, an automation tool for cell depth CO2 diffusion models, co-authored by Professor Gabriel Weiner and myself, Huda Khalil. So the why, or the motivation that inspired us to create this tool. First of all, measuring CO2 concentration levels indoors is essential for maintaining healthy indoor air quality. An important application that has been addressed lately is the use of CO2 diffusion models as an indication or a way to determine the risk of viral infection in a closed space. Also, CO2 concentration levels are used to detect occupants in closed spaces. This information is useful for demand control of lighting and ventilation to ensure efficient energy consumption. The problem is that understanding CO2 diffusion and how the parameters of an indoor space affect it is difficult to achieve by physical experimentation. Therefore, modeling and simulation is the solution to achieve these goals. In previous studies, we have created and verified cellular discrete event specification cell depth models to study the diffusion of CO2 indoors. An example of the applications of such models is understanding the effect of different parameters like the dimensions and the location of the windows on CO2 diffusion. The two videos shown here are for two spaces with different configuration, and the CO2 concentration changes based on the configuration of the different spaces. Handling the steps of creating and changing, reconfiguring the model manually required the use of many tools. This process was time-consuming, error-prone, and unintuitive. Now for the what. What's the model we are using, and what is the tool? The different parameters that we consider in our model are the dimensions of the space, CO2 sinks, and those are doors, windows, and ventilation ports, and CO2 sources, and those are occupants who constantly breathe and add CO2 to the indoor space. As for the tool, CD-Square facilitates creating, changing, and simulating CO2 dispersion indoors. Through a web interface, the user can implement a cycle of features. That starts by converting a simple floor plan into a cell depth model. Second, the user specifies some settings, for instance, the status of the window, closed or open. Also, the user can specify the number of occupants to be generated randomly in different empty locations as cells of type CO2 source. At this point, CD-Square updates the model with the configuration entered by the user and prepares this package to be sent to the next step. Now, CD-Square uses a simulation engine running remotely using the RESTful Interoperability Simulation Environment RISE middleware. So CD-Square calls the APIs to submit the model to RISE, and when RISE is done simulation, CD-Square downloads the results for visualization. Here is a case study showing how CD-Square can be useful. On the left side, we use CD-Square to simulate an apartment with 5 occupants and open windows. And then we simulated the same space again on the right side with closed windows and 15 occupants. It's obvious from the simulation on the left side that different parameters such as open windows can offset this constant increase in CO2 due to breathing. Thank you for listening, and I'll be happy to answer your questions.